We're going to do lesson 3.6 today. I'm going to teach you algebra, which is the commutative property of multiplication. So there's a huge vocabulary word in this. That is the commutative property of multiplication. So this property states that you can change the order of the factors and the product will stay the same. So remember that the factors are two numbers that you're multiplying together, and the product is the answer in the multiplication sentence. So you can change the order of the numbers that you're multiplying, and the answer will stay the same. How crazy is that? So the two ways we're going to look at this are that there are 4 rows of 5 tiles, and there are 5 rows of 4 tiles. See how these both look at the same number? So, for this first one, we're going to think 4 equal groups of 5 because we count rows first. So we've got 5, 10, 15, 20. So it's the same thing as saying 5 plus 5 plus 5 plus 5 equals 20. And when we multiply, it would be 4 equal groups of 5, which 4 times 5 equals 20. Now let's look at it over here. There are 5 rows of 4 tiles. So you're going to think 5 equal groups of 4. So for this one, we're going to count by 4s. So we've got 4, 8, 12, 16, 20. So we would add 4 plus 4 plus 4 plus 4 plus 4, and it would equal 20. And then we can multiply 5 times 4, and that would also equal 20. So the factors are 4 and 5, and the product is equal to 20. No matter what way you multiply 4 and 5 together, they're always going to equal 20. Now, let's look down here. Write a multiplication sentence for the array. All right? So, let's write one for this first sentence. We've got 3 rows here, and each row has got 1, 2, 3, 4, 5, 6, 7 in it. So we are going to count by 7s here, friends. Are you ready? 7, 14, 21. So we've got 3 rows of 7, and it equals 21 is what we just counted. So notice 3 rows of 7. All right, now let's look at the next one. Count how many rows we've got. You count, and then I'll confirm. We've got 1, 2 rows. So we've got 2 rows, and each row has 1, 2, 3, 4, 5 in it. So we've got 2 rows of 5. I'm going to write down the format for the equation. I want you to see if you can plug in the numbers without me. Give you a couple seconds to plug in the numbers without me. All right, let's come back together. So we know that the X, the multiplication sign, means rows of. So how many rows do we have? That's what this first one is saying. We've got 2 rows. And how many are in each row? We've got 5 in each row. So we would count by 5s. And we'd say 5, 10. So our final answer would be 10. Oops, I don't know why it's taking away my numbers. All right, now let's look at question 3. This is an easy one because we only got 1 row. All right, let's see. So we've got 1 row, and the row has 1, 2, 3, 4, 5, 6, 7, 8 in it. So go ahead and plug in the numbers, and then I'll check your work. Remember, this magic little guy here means rows of. How many rows do we have? Awesome job. We have 1 row. And how many are in that row? You got it. We got 8 in that row. So 1 times 8, we just count by 8s. 8. Boom, done. Awesome. So 1 times 8 equals 8. Now I'm going to scroll up a little so you guys can see what I'm working on. Now it says, write a multiplication sentence for the model. Then use the commutative property of multiplication to write a related multiplication sentence. That means one that goes with it. So let's look. Remember, this means rows of. So let's see how many rows we've got here. 1, 2, 3, 4. We've got 4 rows. How many are in each row? Awesome job. You are right. We have 2 in each row. So that's the same thing as saying 4 times 2. So let's count by 2s to find our answer. 2, 4, 6, 8. Awesome. So we know that 4 times 2 equals 8. Now, if we were to use the commutative property of multiplication, that means that we can switch this number, and it will still equal 8. So we're going to bring this guy down here, and we have 2 times this guy down here, 4, and 2 times 4 still equals 8. Now let's go into number 5. All right, I want you to take a minute or two and do it on your own first, and then I'll jump in. All right, I can sense that you are finishing up. Let's count how many rows we've got. 1, 2, 3, 4 rows. So we know that a 4 is going on that first number line. Now we got 4 rows, and we need to decide how many are in each row. So we've got 1, 2, 3 in each row. So we're doing 4 times 3. Now if we count by 3s, 3, 6, 9, 12. Our final answer, you were right, it is 12. Now the commutative property of addition, or multiplication, silly me, says that we can switch these numbers and it's still going to be the same. So we can put the 3 here, and we can put the 4 here, and our answer still going to be 12. It's just like if we were to take this whole array and tip it over on its side. All right? Now, very last one. This looks like a big one. All right, I think you can do it. I'm going to give you a minute or two to do it on your own. All right, let's see what we got here. Let's count how many rows we have. So we've got 1, 2, 3, 4 rows. And how many do we have in each row? Let's see. 1, 2, 3, 4, 5, 6 in each row. So we've got 4 rows of 6. You are so correct. Awesome job. So we're going to count by sixes each time. So we got 6, 12, 18, and 24. My pen isn't working. There we go. So on the first line, we know that our answer is going to be 24. Now, use the commutative property of multiplication and switch those around. Let's see what you got. All right, 6 goes there, 4 goes there, and 24 goes here. So we've got 4 times 6 equals 24, and 6 times 4 also equals 24. You were a rock star today. Awesome job.